So now we know the definition. Let's try this one. Let's say we have a mass and it's going to be uh, moving downward because the influence of gravity. And we have a length which is going to be y. It's going to be the height, I mean. So what we're going to do here is we're going to let y is equals to x. So we're just going to use generated or generalized coordinates, and v squared we're just going to make it as x dot, because the derivative of position with respect to time is going to be dx over dt, and that is another way of representing the derivative. So it's going to be x dot. Now we know the kinetic energy and the potential energy here. It's going to be 1/2 m velocity squared, and the potential energy is mg times x. So what we're going to do is plug it into the Lagrangian equation here. So we have this. So after we have that, what we're going to do is take its partial derivative with respect to x, or we can just take the partial derivative of the Lagrangian with respect to x dot. So for me, let's start first with the partial derivative of the Lagrangian with respect to x. So that's going to be partial derivative of L with respect to x is equal to negative mg. So that's the first equation. Now let's take the partial derivative of L with respect to x dot. So this is going to be mx dot. So now we have this. So if we do have that now, what we can do now is take its derivative with respect to time. So that's going to be d over dt. Going to take the derivative of both sides with respect to time. So here, this is going to be look like a derivative with respect to time of the partial derivative of L with respect to x dot. It's going to be m times x double dot. So x double dot, that's going to be the acceleration, because the second derivative of position is going to be acceleration. So now we do have what we need. So what we can in Lagrangian mechanics. So let's flag it this. So after we flag it in, we can know for sure what's going to be the equation of motion here. What is going to be the